You're listening to a special International Women's Day podcast with Professor Leigh Johnston. Leigh is the Director of the National Imaging Facilities Node at the University of Melbourne. Our mission is to make cutting-edge imaging capabilities accessible to Australian researchers, and we envision a society that provides equal opportunity for people of all genders to learn, work and engage in science, technology, engineering and mathematics. Today we highlight the exceptional work of women leading the way in these fields and thank them for the impacts of their life-changing research. So, let me introduce Professor Leigh Johnston.
My name's Leigh Johnston and I am in an imaging capacity first. I'm the Director of the Melbourne Brain Centre Imaging Unit, which is the University of Melbourne's NIF node. I'm also the head of the Department of Biomedical Engineering.
So, what kind of let you into those two roles?
So I was an electrical engineer, or I am an electrical engineer, and about 5 years ago now, here at Melbourne, we decided that we needed a Department of Biomedical Engineering rather than just having biomechanics people working in mechanical engineering and those of us doing imaging and neuroengineering working in electrical engineering. We all came together out of those departments and created biomedical engineering. And at the same time as doing all my lecturing for engineering and research, I've been working on the other side of campus with the medical people, doing MRI research and PET research. And so kind of, they're somewhat parallel, but they're also completely mixed in. Collaboration between the different disciplines is fantastic. And so our imaging unit is actually based in the Department of Radiography. And so it's a great way to meet people with completely different skills and to mix. Our group is a mixture of radiographers, our PET technologists, MR physicists, biomedical engineers, you name it, we've got neuroscientists. So it's very, very fun, great work environment.
And would you say there are many people with your pretty unique skill set?
There's a few people around, and certainly globally there's a lot of people, but in Australia there aren't too many, I guess. And the wonderful thing about working in imaging research is that people tend to know each other, and it's a lovely group of people that work around Australia, I've got to say. I'm pretty enthusiastic about the whole area, as you can tell. But it's been lovely getting to know people over the last many years now.
So, how long have you been working with NIF?
In a node director capacity, a few years, since about 2018. But I've been involved with NIF longer than that, both through the University of Melbourne and through the Florey nodes, both on the human imaging side and on the preclinical animal imaging side. So it's been a while.
Wow. And I guess you've had exposure to NIF from a few different perspectives then.
Yeah, that's right.
What would you say to someone who's considering either using a NIF facility or joining NIF as a fellow?
That's a great question. So our users, well, for one thing, I can really only speak at this point for what goes on at the University of Melbourne. We have 2 human scanners that aren't in a hospital, right? So we've got a PET CT scanner and a 7 Tesla MRI scanner on the campus of the university, which makes such a difference for psychology studies who want to come and test out functional MRI sequences for some cognitive neuroscience study. The fact that their participants don't have to then go inside a hospital and the researchers don't have to try and get scan time in a busy clinical environment, that makes a big difference. And similarly, a lot of our PET participants, so we do a lot of studies of Alzheimer's, dementia in general, and to have the people for those studies being able to come into a nice, quiet university research environment rather than trying to battle their way through a hospital, it tends to, the users really appreciate it, I believe. Of course, it does, there's trade-offs to everything. And being on a campus site rather than being embedded in a hospital means that we don't do inpatient scanning, for example. Or if we do, it has to be carefully managed, and a clinician coming with the participant across the road. So there's ups and downs to it, but in general, we find it's a really popular setup to have imaging based in a campus environment. And in terms of somebody coming and working for NIF, there's very few jobs as a fellow around that give you that breadth of collaboration. Usually somebody that is a research fellow gets put on one project, it's got very specific goals, and you have to work and work and work for 3 years and publish as many papers as you can, and then you're off and meant to find the next thing to do. And the NIF fellows are a bit different to that, because they're there to support collaboration, which means that they get to keep, many, many different projects up in the air, and they're working on one, and they're contributing data analysis to another, and they're working on a protocol development for another. And I think it just looks like a more interesting and fulfilling job to me. I don't know of any other group of such well-supported scientists and engineers just dedicated to imaging science without it having to be funded 100% from researchers' budgets. That's an amazing thing that we've got in Australia. And I think that's a huge strength of NIF. And I know that personally, we just would not be able to support the number of projects that we can if NCRIS was just a scheme that gave money for the equipment. It's about funding the people, not just the equipment. It's really, really vital part of NIF.
Can you talk me through a couple of your career highlights?
As I mentioned, I'm an engineer, and engineers like to solve problems. And there's a fundamental difference between an engineering mindset and a pure science mindset. In science, you discover things. And so back, we had this idea over 10 years ago about trying to find something called Rabi resonance, which had been known about in the optics quantum mechanics world, and not on the magnetic side of things. And so I had a group of people that, a PhD student started off on the theory, and look, it looks like it might be possible. And then dealing with the equipment that we had at the time, we thought, we'll try and make this work on our very old 4.7T Brooker scanner, where we had, people sitting there pressing a button every minute for hours on end to try and acquire the right data. And the important thing for us was that we took a whole bunch of measurements that were very difficult to get, and they're the dotted. And then if you do simulation and you don't take into account the inhomogeneities in the field, you get this dotted line which doesn't match at all. And then if the theory predicts, and we did the simulations to show this, that you take into account the inhomogeneous fields, and you get this solid line which matches really, really nicely to the experimental data. Now, that's it in a nutshell. I won't describe what it does. It's a phenomenon, but we're very, very excited that it exists, and we can show that it exists. But of course, taking that pure science discovery and actually working out how to use it, that's the challenge. So despite the fact, this paper was published in 2014, we're still looking for the ultimate application of this phenomenon of Rabi resonance that we found. So, but that's how it works. And I'm quite convinced it might take another 5 years, it might take another 20 years, but it's going to be useful at some point. And that's the beauty of working in research. And so while doing, kind of investigating that more blue sky type of research, we do a lot of very, very practical making imaging better.
How does it make you feel to know that some of the work that you're producing has an impact on other people that might change their life?
How does it make me feel? So, look, it's a very satisfying area to be working in, let's put it that way. I actually did my PhD in statistical signal processing, nothing to do with imaging, nothing to do with biomedical anything. It was about making people's mobile phone receivers smaller and lighter and faster. And I was bored out of my brain. I really, really loved the maths, but I just couldn't see the point of it. And I very, very nearly became a patent attorney. Got accepted into the JD that was going to get me there. I'd lined up with a company. I was going to go and do an internship there. And somebody said to me, I think, Leigh, you just may not have found something that you particularly like. You shouldn't give up on research. And I'd been living overseas, and I came back to Australia, and there was a job going, which was a collaboration between the University of Melbourne and the Florey. And they essentially wanted somebody from engineering to be embedded in the Florey and create collaborative links. That was over 15 years ago now. And I had never, ever done any biology, because to me, you did physics, right? You didn't do so much chemistry either, which I now regret greatly, but physics was it, physics and maths. And I'd kind of been very dismissive of biology, and I'm very embarrassed. You know, I'm now the head of department of biomedical engineering, and I was so dismissive of biology. But I saw, actually, I think before I applied for this job back in Melbourne, I attended a workshop which was about brain dynamics, and it was about the maths that models biology. And all of a sudden I was like, oh, hang on, how did I not know this before? And why has nobody told me about this? It was just opened up this completely new area. And of course I went very quickly from just, you know, single neurons brain dynamics to kind of like, oh, hang on, we can do this on a whole brain approach if we use this marvelous thing called an MRI scanner. And so that kind of just opened up a completely different world for me, where the maths and the engineering was applied to something that had a practical and amazing outcome, right? And that then, you know, so I wouldn't say for me it was motivated by the clinical output to start off with, and it still isn't to a large degree. I'm really, really happy that what we do makes a difference to people's lives. But I'm just still like a little kid in the candy store going, oh, I still can't believe that we can take three-dimensional images of what's going on inside people's brains. And that makes me get up in the morning. You know, it's really, really exciting.
That is so cool.
And I'm very, very glad I didn't become a patent attorney. Let's put it that way.
Obviously, STEM is a very male-dominated industry. What advice would you give to a woman starting out in the field?
My advice to anybody who's, let's say somebody that's making that transition from high school into university, for example, or, let's start with that. There's lots and lots of evidence to show, of course, that girls are equally as smart as boys, right? And I would say if you're good at maths, stick with it. If you're good at physics, if you're good at chemistry, if you're good at biology, whatever, stick with it. And when it gets hard, don't just assume that you're bad at it. And this is the difference that I see between and I'm just talking gross generalizations, of course, right? But somehow in school, boys are taught, or it's part of the persona of boys in STEM that they see a challenge and it's like, oh, well, I can do that. You get girls in front of a computer coding for the first time, for example, and they get to a point where they can clearly see that somebody else is doing it easier, and that's because they've had a lot more experience usually, but they go, oh, I must not be any good at this. It just requires a little bit of perseverance and just realizing that even rocket science isn't rocket science, right? You keep plugging away at it, and it eventually, you chip away at it, and it's like, oh, is that all it is? That's not that difficult. I can do that, right? There's been areas of maths that I've gone, oh my goodness, I don't think I'm smart enough for this. And then I kind of chip away and it's like, oh, hang on, I understand this quite well. I can do this, right? It's exciting if you find something that you really like doing. So don't stick in just because you think you're meant to. Like if you like maths, but you're not particularly interested in science, go off and make $1 million, billion, $1 trillion as an actuary in finance, right? There's, if you want to be a doctor, go and be a doctor. And being, let's face it, at the end of the day, if you are happy with your job and your career and you feel satisfied about that, then you're very, very lucky.
Thank you so much.
No worries. Nice to chat, Alex.